Okay, not too many of us this morning, but we're going to go through this anyway. Welcome to our introduction to 3D printing, 3D modelling workshop. Some of the things we're going to talk about today. Excuse me. Let me go back a second. Sorry again. Welcome to our workshop. I'm going to introduce you to a few 3D things in modelling. So what I'm going to do next is show you a little video. It's about a 5-minute video, and this shows you what SolidWorks, which is one of our work programs that we're going to be modelling in today, actually is capable of. So this is a demonstration of SolidWorks itself as a modelling program. And this is from start to finish. let's just introduce in SolidWorks itself as one of our modelling programs. And what you've just seen there is the whole creation progress, all the way from 2D drawings by hand into rendering it into a 3D model. Then you've got simulation, you've got actual design, drawing plans, things like that. So SolidWorks is a very, very powerful program. A lot of those are very powerful like that. We're going to introduce and touch on basic SolidWorks editing today. We're not going into the whole detail of everything. It's about a 16, 17 hour course just to look at some of the different things and possibly a year if you want to be an expert in SolidWorks. But we're going to introduce you into the basic design of stuff. So some of the things we're going to talk about today is what is key modelling terminology. There is certain terminology in all the different programs that you need to understand. What available modelling software there is available. We do have a number of them here in the DSL itself. And modelling and 3D printing, so obviously how we model for 3D printing in that respect. And then we're actually going to do a live demo. I'm going to open up SolidWorks and we're going to create a little part and show you how we go through that step by step. So first thing we need to know, when we talk about key modelling terminology, polygons are a shape, basically a commonly used geometry in 3D printing. And these are used both in 3D modelling, 3D graphic design, game design. When we talk about graphic engines in a game, for instance, they talk about how many polygons you can run at once and how interactive that game is. So polygon is a shape that we're going to understand, and obviously there are various different shapes of types of polygons. The other thing is a face. When we talk about the surface of a 3D print or the surface of a model, we're talking about a face on that, and obviously you can see on the cube there you've got different faces. So again, that's a terminology we're going to use quite a bit. When we talk about vertex, we're talking about the things that connect the little corners. So if you look at all the edges, they're connected by the little tiny vertex in the corner there. And again, it's a way of connecting multiple faces and objects and shapes to create our full 3D model. Lines that we're looking at in the blue there are the edges. So a lot of the time in 3D modeling, we'll use the edge to chamfer or grab or pull or things like that. So edges are going to be worked quite well. Again, when we talk about 3D modeling itself. Now, when we're talking about topology, we're talking about all of the different types of shapes, the triangles, the faces, the cubes, the knobs, and these are all merged together to create the 3D shape, as you can see, and that's interactive. Now, the beauty of when we're using a shape type 3D modeling, that modeling can be made larger and smaller, so we're good to go in that respect. So we can actually create the shapes and size, and you create the different topology as we go through all the design on that. So all of the face and all of the front area here is made up of small different shapes, and that's quite important when you're 3D modeling because you need more of those faces to make sure you've got that smooth interaction there for the 3D printer. Now again, we talk about triangles as the simplest polygon. A triangle is a very, very simple way to create a shape that's sizable. Triangles are very prevalent in STL files, which are for 3D printing. When we save from our modeling program for 3D printing, we're going to save an STL, and an STL uses lots and lots of triangles to create the shapes with as we go through. The other thing that we're going to talk about is extruding. So when we design a face, a 2D flat face, to make it 3D, we pull it out, we extrude it from that, or we cut into it. So extruding is a terminology you're going to hear quite a bit in the modeling software, and it allows you to create all these offsets and geometries and things like that when we're pulling that out. Beveled edging, this is more in certain types of software. So this is the ability to create a specific shape, and then you run that shape around your piece and it will create what we call a beveling, a specific edge. So you can make a custom bevel to sweep through a circle and make a nice smooth edge in your 3D model. It's easier than doing some of the other processes where you're cutting and shaping on that. So you'll hear beveling in some of the terminology out there as well. Now this is quite important in 3D models. It's called a pivot point. Now if you think about a hinge, a window, if you're going to animate something in a 3D modeling program, it has to know where its pivot point is, where is the angle that it's going to go from. Now that pivot point could be a corner, it could be a center, and that's the point of where the swing is going to turn from. It may rotate or it may swing out from that pivot point. And we use that a lot in 3D modeling to actually view things. We'll click on a point and then swivel around that point. So we're creating a pivot point to turn around and animate around things like that. Now this again is something you'll see a lot in 3D printing. Some models have what we call a front and back face. So if you think of a very thin, flat plane, one side of it, like a window, will be the front of the window and the back of the window. Now, a lot of the time, when you download some of the files you may want to 3D print a model with, they may have been made incorrectly, or there's an error in the file which has flipped this around. So if I say the windows here have got a front and a back to them, if I turn that window around, the back is facing the front. Now, it doesn't seem like much of a problem in the modeling because it still sees it, but when you go to 3D print something like that, if one of those faces is turned around, the 3D printing software says, well, it's inside out, so I don't know what to do with that, so it just leaves a hole, it just ignores it. So front and back faces are important, more when you're downloading files because they've not been designed by you. Certain programs like Blender that use a wireframe modeling, they use faces quite a bit, and it's very easy to get errors with those. And if that is missing, it's a terminology called watertight, where something isn't, all the connections out there is not completely solid, so the 3D print program isn't able to see it all, and it creates errors in the actual print itself. Now, key modeling terminology, when we talk about instances. Now, sometimes in 3D modeling with animation and things like that, if you're drawing a battle scenario and you've got hundreds of characters everywhere, what you may do is create half a dozen characters and then replicate them, copy and paste them into your 3D model. So every copy will become an instance, it will become a separate piece, but it's all tied to the original. Now, in animation and 3D modeling, when we change anything in the original, all of the reference parts will change as well. So you can just make one small change in there. Now in 3D modeling, for instance, we're going to put, create like a 3D printing system here, and we'll put little screws and nuts and things like that, and we'll copy and paste and create those. If I change the actual original file, all of the assemblies will update and change with that. So it's a great way to get multiple changes done without having to redo every individual piece. And this is definitely something that's used in gaming software where they have multiple instances of people, horses, where they want to get group scenes and things like that. They can still move them around with algorithms, but the actual instances are the same as the original file that's in there. So again, that's more for animation, but you will see a lot of it in 3D modeling itself. Now, these are some of the modeling software that's available out there. If you look at all the different software on the left-hand side there, you're going to see a ton of different types of software, who uses it in the 3D printing community, and how it's worked through there. Some of the top ones, Sketcher, Blender, SolidWorks, AutoCAD, Maya, these are all used heavily for 3D printing and 3D engineering. Some of the ones we have, the major ones we have, is SolidWorks and Creo here in the DSL. We've also got Blender and we've got AutoCAD as well. So we've got 4 of the main softwares available to use here. ZBrush is a very good piece of modeling software that is more like digital clay. So it's you actually create a model and then you carve it away with digital tools, almost like you would a clay model, so you get some very, very cool stuff. Again, more for animation than 3D printing, but it's a great way to get some fantastic stuff in there. So again, this is just a list of some of the software that's available out there. A lot of it's free and a lot of it is charged in there. Now we're talking about Tinkercad. Tinkercad is a very, very simple 3D modeling software to start with. You can go online, it's an online-based system. It uses rudimentary shapes, so you just pick a shape and drag it in, and then you kind of manipulate that shape to fit. Again, for young children or anybody like that, this is a fantastic piece of software just to start with, to get used to working with shapes and shape-style modeling. Then we move on from that, we talk about SolidWorks. Now SolidWorks is one of the programs over in here. Very, very powerful piece of software. It is industry standard in a lot of places, and you can literally create anything from a pen all the way to a cruise ship with every component in this software. It's very, very cool. Lots of different ways of testing your software, and it's got simulation, you can do animation, you can do actual simulation and testing as far as the stresses. One of the things you can do with SolidWorks and these type of programs, you can assign materials. So there's a whole library of different types of materials, whether it's metal, plastic, glass, and you can assign that to the model, and then all of the simulation understands the stresses and everything on that particular piece based on the material that you've actually applied to it. So again, very, very powerful software to work with. SketchUp is an upgrade to kind of Tinkercad. Tinkercad is a basic, SketchUp is the next level up from that. And again, Google SketchUp is what people use for Google Earth and things like that, and they create all these buildings that they put in Google Earth. So you can do some great work in here, you can use it for 3D printing. It doesn't have all of the tools of SolidWorks and Creo and AutoCAD, but it is a consumer grade. It's free to use, there's no charge for that, so it's a great way to kind of work on that for it as well. Again, stepping up from that, we have Creo, which is another one of the software that's taught on campus here. Creo is another similar to SolidWorks. It's got slight differences in the operating system, but again, it's a very high-end, very capable 3D modeling software if you want to do anything. Some of the engineering classes actually taught Creo as part of the university training, and then obviously this and SolidWorks are your two main ones that a lot of people are going to use in here as well. I'm going to make available on the website all of the slideshow and everything. You'll be able to look at it from the website itself. So this is Blender. Now Blender is more of a wireframe style system. We have it on the computers, and it's basically designed more for animation. If you're doing any kind of animation for 3D, augmented reality, or any kind of video animation, Blender's the kind of program with that. Now one of the things you can do with Blender is you can assign digital photographs as a texture onto the actual surface. So that's how you'll get 3D faces and really high-end design software. So if you're creating characters and you want photorealistic texture, you can do that in Blender, and it's really, really good for making animated style software. And again, very wireframe, a lot of plug and pull and drag on the wireframe, but it's an interesting piece of software, and not too bad for learning. All of the software that we're talking about today, you're going to find there are tutorials online. We're linking tutorials on our website to different places. You can see different types of tutorials and how to work this. And I obviously do a lot of one-to-one work with our students to help you guys learn and work with that as well. Now Fusion 360, this is a fairly new one. It's part of AutoCAD setup. There's a free 3-year license for students to put it on your own computers. Fusion 360 is a combination of 3D modeling software. It also does DXF files for laser cutters, things like that. You can do step files for CNC machines on this one as well as producing 3D modeling files. They all work very, very similar. If you learn one modeling program, it doesn't take too much time to learn another. It's just understanding the individual pieces. But once you get the basics of 3D modeling down, then it becomes much, much easier to interact with different systems. So Fusion, again, is a great software. It's free, it's all been updated, and again, it's an industry standard they're trying to develop all of this through. So what we're going to do when we're looking at 3D modeling is, if we're talking about 3D modeling for 3D printing, some of the things in 3D modeling for 3D printing are completely different to regular engineering or regular build work. Basically, what you can do with a 3D printer is use very organic or very unique styles. You can replicate nature, and that's purely because of the way that 3D printers work. When a 3D printer prints, it uses very thin layering, and it builds almost like stacking drawings of paper on top of each other. And because of that, you can create interior holes, you can create very kind of unique geometry, and it just builds up layer by layer. When you try to do that with engineering or 3D modeling and things like that, when you talk about using a CNC machine, or you take a block of material and then carve it away, you're limited to the surface area, and you're limited to the path that the tool can actually work. So with 3D printing, when you design for 3D printing, you think outside of the box. You can do a lot of things with 3D printing that you cannot do with regular manufacturing. You can create a sphere, or you can create a cube that is hollow inside but is solid on the outside. You can't make that in other systems. So it opens up a world of design, and we recently had a workshop for design students with aerospace, and this is a huge kind of leap forward with aerospace, because they can create very, very lightweight structures, incredibly strong with different shapes that create wing foils and things like that are flexible, that can move. And they couldn't do that before because of the way that things were manufactured. So modeling for 3D printing is very interesting. We do a lot of 3D printing here at the university, and students are actually learning different techniques on how to model for 3D printing, how to get the best system. The other thing when you model for 3D printing it's not just the plastic. You can incorporate in that print, while it's printing, you can have pauses and things like that, where you can put in nut traps or metal bars or electronics. You can actually put them directly in the print and have the printer pause at a certain level to be able to put that in. So it opens up again a world of assembly that you can do while you're 3D printing. You can think about this while you're modeling. I can create a slot there, I'm going to put the chips in, I'm going to put the lights in them, and there is even 3D printing filament that is electronically sensitive, so you can make switches out of plastic that can recognize the tiny pulses from your fingers there. So world of possibilities with 3D printing, and when you're modeling for 3D printing, just take every kind of aspect of what kind of build out. You can build pretty much anything as long as it will fit on the 3D printer there for you. So where we're going to go from there, these are some of the softwares we're talking about. Again, we're going to actually jump into a little place, and these are GrabCAD. These are software that's out there. So if I go to a site, for instance, like McMaster-Carr, which we're going to showcase in the 3D modeling, I can pull a nut, a bolt, an engine block, and pull it into SolidWorks and actually see how they made it, or I can make that part of my assembly without having to model all of those particular things. So there's a lot of places, GrabCAD, Thingiverse, that have all of these files pre-designed on them. And if you're not sure about how to work with 3D modeling software, first thing to do is pull some of these files in, and it shows you a list of how every individual piece was made. You can go through that and see how they did that particular curve, how they cut the threads, how they did the holes, things like that, and we'll showcase that as we go into that. So we're now going to go into a live demo of SolidWorks, and we're going to showcase how that actually works. So let me just go right into here. So this is SolidWorks. I'm just going to turn this and move this around a little bit. Okay, so this is SolidWorks as we've opened the program. So right now we've got nothing in here. So the first thing we need to do is create a piece of modeling platform. So we're going to actually start with a physical model. You've got three different options in here. As you can see, you've got basically a part, an assembly, or a drawing. We normally start with a part because that's how we're going to design our model. Once we've got our part model, we can then open it up and create a drawing from it. If we create multiple parts, we can then assemble them together. So we may be making plates and rods and things like that as separate components and then assemble them in a full drawing, which we'll be able to show in that respect. So the first thing we're going to do is actually open up and create a new part. So we've got this right here. Okay, so now what we have, I'm going to come back here a little bit. So we have basically our file set up. So this is our blank workspace that we're going to look at. Now in the workspace, you're going to see that we have planes. So these are different angles, front, back, left, things like that. We normally choose a plane to start with. So I'm going to choose just the front plane on this one. And then I want that front plane to be straight on. I want to look straight at it. Right now we've got an angle view from it. So if I right mouse click, I've got the ability right here to create the normal to, and that will create me a front view look. So the next step we're going to do, we're going to think about this as though we've drawn this on paper. So we've taken a drawing and we've drawn our part roughly on paper. How do we kind of make that part? How do we create the shape? Now we're talking about a shape. We can grab a little piece in here. One second. So if we talk about a piece like this, how would we create this little piece? So we're going to look at that. If you want to take that a look around. So that's basically a 3D model part. So it's a fairly rudimentary system to do it, but we're going to say how we're going to make that piece. How do we get it to work? So the first thing we look at is the flat plate on the bottom. So we need to create a flat plane. So what we're going to do now, spin this around here. I'm basically going to go up here. Again. I'm going to go up and we've got a sketch system right at the top here. Now with the sketch we have options to pick specific designs. So I'm going to look at a specific shape which is going to be a rectangle right here, and we've got different options to that. We can have different corners, centers, things like that. We're going to start with a center rectangle, and then right in the center here I'm going to draw a rectangle. Okay? So basically that is a basic shape. Now I've not assigned it any particular values yet. So what we're looking at here is we're going to assign some scale to this. So what I'm going to do on the side here, I'm going to select the two, oops, sorry, let's do that. I'm going to select this line, and I'm going to create what we call smart dimensions. So this is how I can assign different sizes to this. So if I click on the first line, and I shift and click on the second line, I've now got a section there that I can create a dimension to. It's going to ask me for the size of that. So I'm going to make that, say 40 millimeters. Now, if I wanted to make that 40 millimeters or 4 inches or something like that, right now it's in millimeters, so my setup is in millimeters. If I want to change that, I can go 40 millimeters and say I want to be 3 inches, 3 inch, and it will then create a 3 inch in millimeters for you. So you can change this size later and make it what you want. So I'm going to go 40 millimeters on the width, and then we're going to go on the same with the height. I'm going to make this 40 millimeters on the height. So again, we're going to 40 by 40 as a little shape. So we've now got a square box. So this is a flat 2D. So this is just the lines that we're showing there. And once we're good with that, we click OK. That's the drawing that's OK. Now what I want to do with that drawing is say, well, I want to make it 3-dimensional. I want to pull it out. So one of the ways you can do that in here at the top, you've got an extrude boss. Two options here. You've got extrude or cut. But right now we're going to extrude. And with our extrude, we've got a couple of options. Number one is that we can actually drag it and kind of pull it out. Or we can set a specific size right here. Now, I know, for instance, my printer uses 0.223 inches as a thickness. So if I do that, 0.223, and then just say inch, it will make that the specific, which is approximately 5 millimeters or 0.233 inches. Once I'm happy with that, I click OK. So what I've got now, I can kind of manipulate this around, is a box. It's just a square box that's got a thickness, a 3-dimension to it. Again, I want to look at that from front end. I've used the normal 2, or you can actually use these spaces up here, will give you different angles and viewpoints, things like that, that you might want to look at. So that's my box. Now, from that box, I say I need to cut some holes. There's some holes I need to put in there. Yeah?
We need to select the material here.
It's not been assigned a material right now. Right now we're just working with a model. When we can assign a material, we can assign it to be metal, things like that, and there's a whole library of materials in here that you can assign straight to that. So that's a little bit later stage on that one. We don't do material on this particular workshop. Material's more of an add-on, but there's thousands and thousands of materials you can apply, literally all types of plastics, glass, metals, things like that. And that's more for doing simulation and design. So right now we're just working with a model. We've got a square model. We want to cut some holes in this. So again, we go back to our sketch. Now I'm going to look for a circle, and I'm going to start right up here. Okay, so I've picked one size. Now I want to make that a size, so I'm going to smart dimension that again. I'm going to click on that and say I want this to be, let's say 5 millimeters in size. So that's now 5 millimeters in size. Now I also want it to be a certain place away, so I'm clicking on the edge with the smart dimension and then saying I want you to be 10 millimeters in. Let's make that 5. Let's go 5 millimeters in. So I've made that 5 millimeters, and then we're going to do the same from the top. We're going to be 5 millimeters from the top. So again, 5 millimeters. So we created the size of the hole and where the hole is in relationship to the top and the sides. Make sense? Now, there's just one hole there. Now, I could do the same for all 4 corners, but I don't really want to do that. So why don't I replicate the holes? Why don't I make them? So if I highlight, just take the smart dimension off. If I highlight this hole now, there's a thing up here called, what do we call that? It's a sketch pattern. So in the pattern right now, it's showing me one extra thing. Now I can add more of those. If I can have 2 or 3, I can come back to the 2. And I can increase the size here where we're at. So that's giving me approximately the right size there. I want 4 on the bottom, so I'm going to add a second row. Now you've got an option here to invert the direction. Yeah. So if I invert the direction, and again I bring this down, I've now got a series of 4 holes. So I'm going to click OK. So what I've done there is created, damn I've created a linear pattern. Now that could be multiple holes, it could be thousands, it could be two, you can separate the distances between them, but it's a great way to get a specific group pattern that you might want for it. So now I've got that, I'd say, right, I've got my drawing, what am I going to do with it? I'm going to extrude those, I'm going to make them pillars, or I'm going to cut in. So right now I want to cut holes on this. So I'm going to go to the extrude cut section. Now extrude cut gives us a few options here. Blind means I tell it how deep it's going to cut. Is it going to cut through everything? You've got all sorts of other options on here. When we talk about that, we can through all, which will cut all the way through any model or anything that's in behind that. And you've got to next, to depth. So you've got a number of options there of where you might want that hole to, or the extrude to cut into. We're going to cut all the way through. So we want through all to cut all the way through. And then we've selected that. Again, we can have the direction, is it going to cut upwards, is it going to come backwards? So as it is right now, it's cutting in. When I click OK, we've now got our holes and they're all the way through. Yeah? So let's say we want a little pillar or something off this. So again, we're going to bring this center on, and I'm going to create a nice little square or something in the center. So we're going to create a little box. I'm going to kind of have that right about here. Okay. Now again, I can size this. I can make the sizes where I want them with the smart dimension. Again, we'll click on top and our bottom. And we're going to make that 20 millimeters. And we're going to do the same with the sides. There we've got that 20 millimeters again. So that's a square 20 millimeters. Again, we want to extrude that. So how tall do we want that to be? I'm going to bring that up to about 40 millimeters. So I'm going to click OK to the drawing. Going to go up to our extrude boss. And then right here, I'm going to select a specific height, 40 millimeters. And click OK. So what we've got now is a nice box. Yeah? So we've got a pillar or something like that. So let's say I want that bottom to blend. I want it to smooth in. I want a nice curve in that. So what we do there, we select the faces. And when we talked about, the edges. When we talked about the edges before, this is where you can work on different edges. I can spin this around, select different edges as we go around. Press the shift key as we go. Okay, so I should have one, two. Let's make sure. We're pressing the shift key to multi-select. So I've now got all four edges selected. Yeah. Now, if I want to smooth that in, a couple of ways I've got fillet and I've got chamfer. Chamfer is more for cutting a clean edge off. A fillet will create a smooth. So I'm going to create a fillet on that edge. And then we're going to say what size we want. Let's make that. What have we got there? So what we've created there, can you see the smoothness? Now that's a little big. I don't want it that big. I want to cut it back a little bit. So I can go back and edit the part right here and actually make that size. Let's make that 5 millimeters. And then let's take a look at that. There we go. So that's a little softer. So what we created there is a nice smooth fillet to give us a nice curve on that. And again, we want to do some other things in here. Let's say we want to cut a hole in the top, but we don't want it to go all the way through. We want a specific hole, and let's say we want to put a nut trap in there for a bolt. So what we can do is create, and let's create a, what's my hexagonal. So we've got an option to create a nut bolt, how many sides that we want, and again, we can kind of size this up and create our bolt right there. And then we can adjust all the sizes to match the measurements of the bolt that we're actually using. So again, once we've got that, we click OK. And then we're going to actually drop that in. We're going to cut that in to hold the bolt. So what we're going to do right now is go into our extrude cut, and we're going to cut that down. Let's say that's 5 millimeters is the thickness of that particular bolt. And click OK. So what we've now got is a 5 millimeter hole. So when we talk about a nut trap, we're talking about, I'm going to make something on this, I'm going to put a metal bolt in there, and that nut is going to sit in that little trap, and when I tighten it up from behind, it's going to hold on to that really tight. So again, what we've got here, let's come to the face on that, is a nut trap, but we need a hole. We need the hole for the actual thread. So again, we're going to go back into the sketch, create a hole right in the center, and then again, I'm just going to guess this at the moment. We can actually tell it what size the hole is if we want it to we can create our smart geometry if we want to make it specific size. So if I go to smart dimensions again, double click my hole, I can make that right now. It is 6, so let's make it 6 millimeters. So that's my bolt size. Now again, I'm going to cut this through, so I'm going to go into, my setup and use extrude cut. And again, we're going to cut through we're going to cut it all the way through. Okay, so what we've got now is a nut trap and a bolt that you can actually screw through. You'll be able to hold on there. Now let's say I want to see something in the side here. I can click on the face, bring that up, and again, I can basically create in a drawing. Now let's say I want to make an unusual shape, so I can basically take a polygon line command or a line command like this, and I can create a kind of weird looking shape using a hand-drawn system. Once you've got the shape, you're good to go again. You can say, oh, I want to extrude that all the way through and create kind of an unusual cut through. You can add text, for instance. If I want to add text, I'm going to keep this here. We go to our sketch file, add text right here, and then basically you can add our text, which we can click into here. Now, again, you can change the fonts and things like that. You can change the size, you can make it bold. But once you've got your position in there, you can actually move it where you want it to be. And again, with smart dimensions, you're able to size that. Again, with that, we've created a text. Now we're going to say we want it large. So I'm going to bring it out 1 millimeter. Okay. So what I've done there is created text on, so you can cut in or you can pull out. And again, if I think this needs to blend in, you can create the edges of that text. You can blend in that text with a merge and give it a little chamfer on that edge, which I just did just by chamfering a little bit with a 0.1 millimeter. So the ability to create all of these different shapes. Now, some of the things you can do, which is very interesting, if I go to McMaster-Carr, for instance, so McMaster-Carr, now this is a repository of different things. So let's go to nuts and bolts, and let's say I want this bolt as part of my selection. I'm going to click on that bolt. Now on the parts, so if I create a part number here, click on that. In the parts on SolidWorks in McMaster, you've got product detail. Now once you've got product detail, you're able to say, right, I want a SolidWorks file. So I'm going to save that file. I'm going to save that file. And I'm going to open that file. So I've already saved it. I'm now going to open it. It's now opened in SolidWorks. And on the side here, I can see all of the different things that have happened with that particular part and how it's been made. So you can actually bring it into SolidWorks and look at it and kind of make this part of your assembly when you're doing that. So again, you can go to McMaster-Carr. There's lots of different things you might bring in. Let's go something a little more complicated, a bearing, for instance. So let's use a bearing. Let's take this one, take the part, come down, product detail. Let's say that's a SolidWorks. So this is a multi-assembly file, which we've got multi-assembly parts. And you've got all the way that that's been built right here. So the beauty of this is you can bring something in and see how did they do that thread, how did they do that burring, and all of the steps are right here. You can go through them all and edit them. You can literally go into and say, well, edit that particular piece. And then you'll be able to go in, and there it is, you can see different edits, you can play with it, things like that. So it's a great way to work with component parts in SolidWorks. And I use this a lot. For instance, if I buy bolts from McMaster, which I do, I don't need to model them to put them in my drawings. I just bring the drawing in and put it as part of the assembly to showcase it in your full model. So a couple of other questions finally when we talk about SolidWorks. So let's keep that open and go back to SolidWorks again. So I'm going to open up. I'm just going to open up a part instead of redrawing the one we already did. Let's go back to here. Let's take a nice note or something like that. Okay, so I've got a complete part now that's been designed, so I want to print this now. So how do I send this to be a 3D printed job? So the file is already in there. What we do now is we go to File, Save As, and in the Save As we get the option for what we call an STL file right here. The STL file is what you want for SolidWorks. Now a couple of things you want to look at. When we're looking at the STL file, we're talking about options as well. So in the options, this deviation right here is how we get the smoothness. If I bring that down quite a bit and click OK and save, can you see how it's got so it basically doesn't give it a smooth. So if I want to save that as a high resolution or something, so if you've got a circle, you want that to be as smooth as possible. So what you're going to do in your options, what you're able to do, when we create an STL file again, we're going to create STL. In the options, you push this deviation up so the tolerance is higher. And what that does, it creates more faces. So when it prints smoother. So the more faces you've got, the smoother it's going to be. And when we actually click OK on that, you will see how smooth those circles are now because we've added more faces. You can see here it's much, much smoother. If I did that less, you'll have less faces, so it becomes more blocky in that respect. So that's basically the basics of editing and building 3D modeling programs and how we get there from that particular stage. So basically at that point, that's going through the actual modelling programming, how we look at it. We've seen how we can create the model from a 2D drawing, extrude it, cut holes, things like that. There are many, many other things that the programs are capable of doing. And obviously you go through that step by step. Again, if you go to the library website and look at the DSL and then click on technology, we have links to the software. We've got training videos on that. And YouTube has got lots of training videos on SolidWorks. SolidWorks themselves have free training videos. And all of the other programs will have training videos. So depending on what you want to do, don't try to do everything at once. Start with one model and then go from there. Say, I need to create this model, learn what you need to do for that particular process, and then bring it in. And again, if you're not too sure about how to cut threads or things like that, you can go and download those files from McMaster and have a look at that. Some of the beauties you can do with downloading files is I can use a McMaster bolt and apply it into my model, and it will cut the thread for me. It will actually cut out the space exactly for that thread. So you can do all of that kind of thing with the modeling programs and things like that. So if you've not done any modeling before, maybe start with Tinkercad, maybe start with Google SketchUp, just to learn the basics of object modeling, and then take a look at SolidWorks or Creo or AutoCAD, whichever you prefer to work with in that respect. Any questions? Yeah.
I'm a mechanical engineering student.
I'm sorry?
I'm a mechanical engineering student, and
Oh, chemical engineering, yeah.
mechanical.
Oh, mechanical, yeah. Yeah, so you guys will normally do some 3D modeling in part of your classes?
Exactly. So, what do you recommend? Laptop requirements to support all these softwares, SolidWorks and Creo and all these softwares. What do you recommend for a laptop?
It really depends where you're comfortable. I know engineering like Creo, which is one of their softwares. We've got Creo, SolidWorks, Blender, AutoCAD on our systems. If you're going to do modeling for engineering, I would say work with Creo or SolidWorks, whichever you prefer to work with. Those are the two core programs that engineering companies use outside of the university. So when you go for a job as an engineer, you need to know a specific program. And once you've learned that program, look at what the companies are, and go and research and say, what are you using for 3D modeling? Are you SolidWorks, Creo, or AutoCAD? And if that's the direction that you're going to go into job-wise, learn the software that they use, and then you're already set for that.
Yeah, I'm asking about the requirements for a laptop that can support.
It really wants to be, with SolidWorks for instance, it wants about 8 gig of memory, a decent like an i5 or equivalent processor in that to run it, and a lot of storage space, because you're going to run a bit of memory. The more memory, the better. If you've got 16 gig, anytime you're working with modeling files, you want a lot of memory as you can, because basically those files can build up very quickly if you're doing complicated models. So minimum spec for SolidWorks is 8 gigabytes of memory, and probably an i5 or equivalent processor, or anything faster than that will be better. Any other questions? Well, that is the end of our workshop. Thank you very much for coming. Thank you once again for seeing you again. We'll see you guys on Friday. We're still working, finishing up our printer and stuff, so we're going to be good on that. Other than that, you guys have a great day. Thank you. And again, my contact details are right here. Call me anytime if you guys got any questions on 3D modeling or anything like that popping. I'm here every day, so come and see me. We'll get you guys sorted out.